Hello children, this is class 12 Applied Mathematics term 2 blueprint, that is chapter wise weightage. In that we have calculus for 9 marks, inferential statistics for 5 marks, index and time series for 5 marks, and financial mathematics 15 marks. One more chapter, linear programming, is for 6 marks. So among these 5 chapters, financial mathematics holds a bigger weightage. That means 15 marks, almost half of the marks. We are going to write the exam for 40 marks. So financial mathematics, we will deal with financial mathematics. In that, the very first part is perpetuity. Perpetuity, it is this is how the financial mathematics in your class is designed. Perpetuity, sinking fund, valuation of bonds, EMI, CAGR, returns, stocks, shares and debentures, linear method of depreciation. In this, among all this content, the stocks, shares and debentures are deleted. The remaining things we are going to see one by one. So before that, we will have a recap over what we have learned in this content in the class 11. Annuity. Annuity, we know it's a series of payments made at equal intervals for any purpose. It can be a saving or it can be any reimbursement. For any purpose, it can be a regular payment. It can be, by the name annuity, we should not think that it is only meant for annual returns. It can be paid quarterly, half-yearly, monthly, even weekly. Any other interval of time but in a regular interval. That annuity is generally divided into 3 types. One is ordinary annuity. Ordinary annuity means immediate annuity. That means the payments, whatever we use in our regular life, the payments will be made at the end of every period. End of the month or end of the year, end of 6 months likewise. But annuity due is like an education loan or LIC health premium you are paying. These payments are the deposits. These payments we will be paying at the beginning of the month. Such payments are called annuity due. So ordinary annuity is a very common annuity which we pay in the end of the month. Annuity due is the special annuity which we pay at the beginning of the month. The third type is deferred annuity. Deferred annuity is a separate one which is not most applicable. Few cases only it will be there. That means, for example, I am applying for an education loan. Immediately I won't be paying the loan. After education I cannot pay. Till I complete my course, some certain years I won't be paying the dues. After that, either I got the job or I completed my course after some time completion. Then after some time only we will be repaying the amount. Such a cases the payment is called deferred annuity. So these are the 3 types. Most probably in the mathematical concepts we will be using ordinary or annuity due. So future value and present value. When you consider an amount, now I am having 1000 rupees. If I deposit this 1000 rupees for 5 years, each year I am paying 1000. End of the 5th year, I will be getting 5000 rupees plus a compound interest for the amount which I am depositing each year. Right? In total, I will be getting some extra amount. So, today the 1000 rupees which I am paying is the present value. In future, how much I will be having, the value of this money in future which I am getting is called future value. Or suppose I deposited some amount, they didn't mention the amount. I deposited some amount. 7 years, after 7 years I am getting back 1 lakh rupee. So that 1 lakh rupee is the future amount. For getting 1 lakh rupee, how much I am spending today or how much I am depositing today is the present value. This is the concept of present value and the future value. So the formula will be of little vice versa, same. Both are derived from the compound interest formula. So future value is cash flow or every month cash payment. Cash flow into 1 plus I power n minus 1 by I. So future value will be increasing. So n is positive. The power n is positive. Present value is c into 1 plus I power minus n, then minus 1 by I. This is from the future value. You will be traveling back. So the power is negative. This formula is for ordinary annuity. You all know ordinary annuity is payment made at the end of the term. So suppose if the payment is made at the beginning, annuity due means the same future value formula will be the same like the ordinary annuity, but 1 plus I will be extra in product because 1 month before at the beginning itself. So one installment will be extra. That is why. So 1 plus I power n minus 1 by I into 1 plus I. Same way in the present value also c into 1 plus I power minus n the whole minus 1 by I into 1 plus I. This is the value for the present value and future value in regard with ordinary annuity and the annuity due. Now, the present value is always cash flow divided by 1 plus I whole power n. C by 1 plus I whole power n. Okay. The present value of an annuity is the current value of the future payments from an annuity given a specified rate of return or discount rate. The higher the discount rate, the lower the present value. When you are giving more discounts, your present value will be less. So present value accounts for time value of the money. Time value of the money. It's just a calculation. Because of the time value of money, a sum of money received today is worth more than the same sum at the future value, because the worth will be more when you get it in present. Okay. So this is how they are explaining about the present value. Then what is perpetuity? It is also like an annuity only. The same periodic payments, but here the payments starts on a fixed date and continue forever. There are two conditions. For example, the pension bonds. What are the conditions for the perpetuity? How the perpetuity is continue forever? Either you are depositing some amount and getting the interest for that. Till the amount is in the bank, you will be getting the interest. Or till you are alive, you paid an LIC policy. Till you are alive, you will be getting the amount. Till you are dead, you will be getting the amount. So perpetuity is a type of annuity. It's a type of payment which you receive in a regular interval till you are alive, or the amount which you paid or deposited is in the bank or in the institution. This is a perpetuity. So perpetuity is of two types. Type 1, same like how the annuity is payment made at the end, payment made at the beginning. Same way the perpetuity has, because it is also a regular payment. Same like annuity. So this is also taken as type 2, two types. So perpetuity, we will continue it only for the present value, because what is the present value that gives you this much installment or this much payment at the after your depositing time. For example, I am depositing 5 lakh rupees. Now, after 10 years or after my retirement, I will be getting monthly 5,000 rupees till the end of my life. So to get the 5,000 from the age of 61 till the end of my life, they will calculate it approximately 99 years. So almost 33 years into 12 months, how much amount it will be to be deposited today to get some 5,000 in the future. Such a way they will be calculating. So it is most probably related with the present value which you are installing. Okay. Then how to get a formula for the present value of the perpetuity? We know present value is cash flow by 1 plus I. If you are paying monthly or your payable amount at the end of each period is rupees R means R divided by 1 plus I is the present value, right? So by 1 plus I will go to the numerator and become 1 plus I power minus 1. That is why here we have written R into 1 plus I power minus 1. This is the payment made at the first month. Present value of the payment made at the first month. Present value of the payment made at the first month. Simply you can write R by 1 plus I power n. Second month if you keep paying, what happens? Into R by 1 plus I power 1. 1 into 1 power will be added, it will become 2. Same way for the third month it is 3. Likewise it is going on. When you compare these terms are looking like GP. See, all the numerators are same, but the denominator power is increasing. So you can compare and find the common ratio as 1 by 1 plus I. So consider this as a GP. GP of continuous terms, infinite terms. What is the summation for GP of infinite terms? A by 1 minus R. What is A here? When you take R common, the A is 1 by 1 plus I power 1. So this is your A. So take that A, divide it by 1 minus R. R is 1 by 1 plus I. 1 minus 1 by 1 plus I. If you take LCM and simplify, R into 1 by I you will get. So that is R by I. So present value of the perpetuity is R by I. Suppose if you pay the payment at the beginning of the month, you are getting the payment at the beginning of the month. So same terms like type 1 from the month end till your period, if you add from here from 1 to all this, if you add, you know the formula is R by I, right? Simple way I am telling, R by I. But in the beginning 0 period itself I made one payment, no, that R is extra. So R plus R by I am getting. This is the formula for type 2 in which the payment is made at the beginning of the month. So these are the two formula for perpetuity. One is for the annuity due R by I, another ordinary annuity R by I, annuity due R plus R by I. These are the two formula. Okay. So here we will see some examples which is given in the student support material introduced by CBSE. Example 1. Find the present value of a sequence of payments of rupees 60 made at the end of each 6 months and continue forever if money is worth 4% compounded semi-annually. Here they are telling in the sequence I am getting rupees 60. The payment is made as rupees 60. So we know the cash flow is 60. So R equal to 60. And they have very clearly told in the question at the end of each 6 months. So end of means it is annuity ordinary. So formula will be R by I only. Perpetuity will be R by I. At the time period of 6 months. That means interest compounded semi-annually, half yearly. But the interest given here 4% is R. In the question, throughout the financial mathematics chapters, you will be given only annual interest. Near the interest, they will be mentioning whether it is compounded annually or semi-annually or quarterly. But the given rate of interest is R. If you want semi-annual interest, you have to find I. How to find I? For semi-annual, divided by 2. For quarterly, divided by 4. So here, I is R by 4. R is 4%, no. 4 divided by 100 is 0.04. So that is divided into half, 0.02. So I is 0.02. So the present value of the perpetuity is equal to R by I, 60 by 0.2, 0.02. So here two decimal places are there in the denominator. Multiple both numerator and denominator by 100. So numerator becomes 6000, denominator becomes 2. 6000 divided by 2, 3000. So the present value of the perpetuity for rupees 60. That means In future, you will be getting 60 rupees. For that, you have to pay 3000 rupees now. Okay, so present value is 3000 rupees. Same way, example 2, at 6% converted quarterly. Find the present value of perpetuity of rupees 600 payable at the end of each quarter. So, what are the clue here? One is compounded quarterly, rate of interest is quarterly, and the second thing is end of each year, so ordinary perpetuity. So cash flow is 600, it is given in the question, it is 600. Then rate of interest is also 6%, 6% means 6 by 100, 0.06. As it is quarterly, I divide it by 4, so I equal to 0.06 divided by 4, 0.015. So as it is perpetuity of ordinary, so present value of the perpetuity is equal to R by I, 600 divided by 0.015. Here 3 decimal places are there. So multiply the numerator and denominator by a 30 number, 1000 by 1000. So numerator you will be getting 6 lakh divided by 15. In answer you will be getting 40,000. Next, at what rate converted semi-annually will be the present value of the perpetuity of 450 payable at the end of each 6 months, rupees 20,000. B, rupees 20,000. To get rupees, at what rate converted semi-annually will be the present value of the perpetuity of 450 payable at the end of 6 months. B, 20,000. That means the present value is 20,000. If you pay 20,000, in future you will be regularly getting rupees 450. The payment will be made at each 6 months. What is the rate? I, we have to find the I first. So in the formula we know the payment is made at the end, so our formula will be R by I. They have mentioned the cash flow is 450. Be very careful. The 2000 is the present value. 450 is the perpetuity cash flow. So 450 divided by I equal to 20,000. So cross change this. I equal to R by P, that is 450 by 20,000. If you divide it, you will get 0.0225. We know it is compounded in 6 months, so you would have divided the rate of interest by 2 and you would have got this I. So if I is R by 2, R by 2 equal to 0.0225. So this 2 will go to the other side. When you transfer, it becomes a multiplication. So R becomes 0.045. That is 4.5 percentage. You wanted to convert anything into percentage, you multiply it into 100. So 0.045 into 100, you are getting 4.5, the percentage rate of interest. Sometimes you will find I, but you will forget to convert it into R. So be very careful. Rate of interest means we have to present R only. Then example 4, how much money is needed to endure a series of lectures costing 2,500 at the beginning of each year if the money worth 3% compounded annually. So 3% rate of interest is 3%. It is compounded annually, so no need to divide it by any number. I and R are same here. So I is also 3%. 3% means 3 by 100, 0.03. 0.03. Now they told the cash flow will be 2,500. So at the beginning of the year, they clearly mentioned it is the beginning. Beginning means the formula will be R plus R by I. Just apply it in the formula. 2,500 plus 2,500 by 0.03 multiplied by 100 by 100, then divide the value by 3, you will be getting 85,833.33. The 33 will keep going. No problem, you can stop it in the second place. Example 5. The present value of a perpetual income of rupees X. The cash flow, they have mentioned it as X. At the end of each 6 months, so the time period is compounded half yearly, is rupees 40,000. So the present value is 40,000. Find the value of x if the money worth 6% compounded semi-annually. So the rate of interest is 6%. When you compound it semi-annually, you have to divide the 6% by 2. That means 6 by 100, 0.06. Divided by 2, you are getting 0.03. You know the formula is R by I. Present value is 40,000. R you don't know, so you left it as x. So 40,000 equal to x by 0.03. Just you multiply 40,000 with 0.03. You will get 1,200. That is your x value, cash flow in every 6 months after certain period. Then exercise 7.1. Same student support material. CBSE student support material. Exercise 7.1 question 1. Find the present value of a sequence of payments of rupees 80 made at the end of each 6 months and continuing forever if money is worth 4% compounded semi-annually. So what are all the clue we have to listen to? The payment is made at the end of each year. So formula present value is equal to R by I. What is I? R is 4%. I will be, as it is semi-annually, I will be 4% divided by 2. 4% is nothing but 4 by 100, 0.02, right? 0.04. When you divide it by 2, you will be getting 0.02. That is I. So 80 divided by 0.02, multiply the numerator as well the denominator by 100 to remove the decimal in the denominator. So 8,000 divided by 2, you are getting 4,000. So the present value of the perpetuity is 4,000. Question 2 in the same exercise. Find the present value of an annuity of rupees 1,800 made at the end of each quarter and continuing forever if money is worth 5% compounded quarterly. Find the present value of an annuity of rupees 1,800. So annuity, that means the perpetual amount which you will be getting is 1,800. Cash flow is 1,800. Payment will be made at the end of each quarter. Quarter means R will be divided by 4. What is R? 5%. So capital R, that is cash flow 1,800. R is 5%. So 5% divided by 4, you are getting 0.0125. Okay, 5 divided by 100, the whole divided by 4. So 4 means 4 by 1. A fraction divided by another fraction, I am reciprocaling and multiplying it. So 5 by 100 into 1 by 4, when I cancel it is 5 by 400. So when you simplify this, you are getting this value 0.0125. So now the perpetuity is the cash flow by the I, 1,800 divided by 0.0125. Multiple the numerator as well denominator by 10,000, which has 40 to remove the 4 decimal places in the denominator. The numerator, how much you are getting? 180 lakh divided by 125, you are getting 1,44,000 rupees, the present value of the perpetuity. Question 3. If the cash equivalent of perpetuity of rupees 300 payable at the end of each quarter is rupees 24,000. Find the rate of interest compounded quarterly. So we have to find the R. As the interest is compounded quarterly, it would be I would be R by 4, right? So cash flow is 300. The payments are made at the end of the period. So perpetuity equal to R by I. And the present value is 24,000. So 24,000 equal to 300 by I. Exchange this I with 24,000. I equal to 3,000 by 24,000. 300 by 24,000. Cancel 2 0 with 2 0. 3 with 24. So 1 by 80 you will get. 1 by 80 when you divide it you will get 0.0125. 0.0125. This is nothing but R by 4. I is nothing but R by 4, no? So R by 4. Now this 4 will go to the right side and multiplied. So 0.0125 into 4 equal to 0.05. 0.05 is nothing but 5 5%. 5%. So the rate of interest is 5%. Question 4. Find the present value of the perpetuity of rupees 780 payable at the beginning of each year if the money is worth 6% effective. Present value perpetuity payable at the beginning of each year. When the payments made at the beginning, the present value of the perpetuity equal to R plus R by I. That is the formula. And what is R? R is the cash flow, rupees 780. And 6% is small r, rate of interest. As there is no clue that whether it is compounded quarterly or half yearly, so we can take it as annually. So 6% will be taken as such 6 by 100. 6 by 100 is 0.06. So the perpetuity equal to R plus R by I, 780 plus 780 by 0.06. That is 780 by 0.06. After removing the decimal places, if you find the value, you will be getting 13,000, because we are multiplying the numerator by 100, denominator by 100. That's why. So 780 plus 13,000, you will get 13,780. That is the present value which you have to make now to get 780 rupees in the time period of a year. Okay. So question 5. The present value of the perpetual income of rupees X. Income of rupees X means the cash flow is rupees X. At the end of each 6 months, the payment is made at the end, and that too of the 6 months time period, is rupees 36,000. Find the value of X if the money worth 6% compounded semi-annually. So we know the cash flow is taken as X and the present value of the perpetuity is 36,000. Rate of interest is 6% per annum. So when you make it as semi-annually, R equal to 6%, I equal to 6% by 2, that is 3%. 3% is nothing but 3 by 100, 0.03. So the perpetuity at the payments made at the end, the present value of the perpetuity P equal to R by I, that is X by 0.03. P is nothing but 36,000. Cross multiply it. 36,000 into 0.03 equal to 1080. So the cash flow is rupees 1080. The cash flow is rupees 1080. So in this exercise 7.1, few more sums are there, but the first 5 sums are only meant for perpetuity. So we'll see the remaining sums in the next content. Hope this will be helpful to you. As I made all the detailed answers here, I am just presenting it. Remaining questions I will solve and show you. If you want more practice the same pattern sums using your ML Agarwal practice books. Okay. Thank you children. All the best for your exams.